So for the first one, delta S for precipitation of lead 2 chloride. We're precipitating something, so we're forming PbCl solid from the chloride ions and the lead ions, 2 of those. And so you're going from, a lot of disorganized, messed up, aqueous stuff to a solid, a more organized piece. And so since you're going from disorganized to organized, you actually say that it is negative because it's becoming less disorganized or more organized. So minus sign there. The next one, delta H for freezing from water to ice. So we're going from H2O liquid to H2O solid. So when you're going from liquid to solid, you're becoming, you're losing energy. And remember, H is energy. And so the enthalpy change of that would be negative. You'd be giving off energy from the system. The next one, delta G for melting ice at its normal melting point. So you're at 0 degrees Celsius, and at 0 degrees Celsius, water can be a liquid or water can be a solid. It will switch back and forth between these two, and we say we're at equilibrium. And when we're at equilibrium, the Gibbs free energy is equal to 0. So when you're at equilibrium, you're 0 right here. If you were at a different temperature, of course, then you'd be able to say whether it's negative or positive. Delta S for boiling water to steam. So now we're going from liquid to gas, and so you're going from a fairly organized liquid state to a random, very disordered gaseous state. And so you say that the entropy is positive. Letter E, for this one, you're going from 3 moles of gas on this side to 2 moles on this side. So since you're reducing the number of moles of gas, you're organizing it more, and so entropy is negative. And then lastly, the delta G for a reaction with K equal to 10 to the 6th. You can know this a couple of different ways. First of all, know that when your K is greater than 1, you favor the products. So you're going to make lots and lots of products. And when you make lots and lots of products, your delta G is going to have to be spontaneous, or you're going to have to move in the forward direction spontaneously. Or the other way you could know it is that G is equal to negative RT natural log of K. And if K is really, 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 really big, that means G is going to end up being negative. So you can know it either way. Questions on that question number 1 for response? Okay, question 2, probably the easiest one on the test, maybe second easiest. You have to write the equilibrium constant expression for the reaction, and notice this is a solid, so it's not involved in it. So you simply write down this guy right here times this guy right here to the first power. Call them each x, and then you got to solve for x. So x squared is equal to 0.04. Square root both sides, and you end up with x equaling 0.2. Put your units on there. It's in atmospheres, and you win a prize. Questions on that one? Okay, number 3. Number 3 was a little confusing because there were some values in the text, different values in the table. And so I used the values in the table. They will be the same on the actual test. But filling in the table, lose x, gain 2x. Why 2? Because there's 2 of this thing right here. And then it'll be the original or initial minus x, the original minus x, and then 2x over here. And then it's products divided by reactants to the power of the coefficients. So I plugged in the products squared, reactants right here to the firsts. Took this value and put it in for Br2. Took this value, put it in for Cl2. Took this value and made sure to square it. Once I did that, squared it right here, 4x squared. This one you have to use FOIL, first, inner, outer, last. And so you end up with all of these creatures, and it equals 10. Where do you get 10? Up here it tells you k is equal to 10. So this whole thing right here is equal to 10. And now I combine my terms, those two terms right here. That would end up being negative 6.5x. And I take this entire grouping right here, multiply both sides of the reaction by that, or equation. So then I end up with 10 times this thing. And then I set the whole thing equal to 0. If you remember back from your study of quadratic equations, if you're going to use the quadratic formula, you got to set it equal to 0. And I bring 4x squared to the other side of the equation to set it all equal to 0. Distribute the 10. Once I do that, I distribute the 10, combine my x squareds. 10x squared minus 4x squared gives me 6x squared, and then I just say solve for x. Please don't solve it. You might have the quadratic equation solver in your calculator, but you won't get any more points for actually solving it. Questions on 3. All right, number 4. Probably the toughest question on the test. Maybe not, maybe. First one, read it carefully. It says it is not first order. So knowing that it's all you have to prove is it's not first order, is pick anything on this chart right here for first order equations and try to shove the data into it. If it doesn't work and if it's not consistent, then you've proven that it's not first order. So you could, since they give you a bunch of times right here, put these numbers into the half-life equation right here. And if k is not consistent, you've proven it's not first order. You could also take the natural log of all of these things and graph them as natural log of concentration versus time. And if it's not a straight line, well, then it's not, it's not a first order. The other thing you could do is you could take the natural log of these numbers right here again, and you could find the slope. Change in y over change in x. Pick 2 points and do change in y over change in x, and then pick 2 other points. If you find out that the slope is not the same, it means it's not a straight line. So that means it can't be first order. So you're just proving that it's not first order. I wrote down a couple of ways to do it. If it's first order, the half-life follows this, and try a couple numbers. If it's not the same, it's not first order. You could graph it. If it doesn't fit this with a straight line, well, then it's not first order. So there's more than one way to do this. Pick your favorite way. Second one, prove that B is first order. You could do the same things that I said for A. You can go ahead and plug it into the half-life equation. K should be the same for every half-life value that you choose. You could also simply compare the slopes by comparing the two sets of times. I chose 2 and 0, and then I chose 10 and 8. And it turned out that they had the same ratio. You could also graph it, and if you graph the natural log, was I pointing to A? I apologize, I meant B because it's the B values. And then graph the natural log of concentration of B versus time. It's B that this one is asking about. I apologize if I was pointing to A. Yes, question?
So for the half-life, I don't understand what we plug in. Like, we don't know the half-life or K.
So if you look here, you could figure out what half of something is from this data. So you could say 0.1, what would be half? Like 0.5 would be half in A. That's an easy one to do. Okay. And then you could say that took 4 seconds, right? Okay. Well, to reach another half-life from 0.05, it should take 4 more seconds. Okay. Well, what happens when I get to 8? Oh, it doesn't work. It should be 0.025. Oh, so that proves that this is not first order. For those of you watching the video, she asked the question, how can you look at that half-life pieces and find out that they're first order or not? And I pointed out A because it doesn't work. And then in this one, I just took the numerical values here of 2 different times and compared them, and then 2 different times and compared them, and notice they're the same. So if that happens, then you know that that's going to be first order. And then graphing it is easy as well. If you have, well, a graphing calculator. Or I suppose you could take the natural log of them and sketch it. That would be okay. Find the rate constant for the decay of B. So you could find the slope of the line if you graphed it. That would be okay. Change in y divided by change in x. Or just pick a point. This is probably the easiest way to do it. I picked 6 seconds, and then take it and put it into the first order integrated rate law equation right here. I know the original concentration is 0.1, so put that in here. And then I picked 6 seconds, so at 6 seconds is 0.03, so that goes here. And then I put 6 seconds in here and I solve for K. You don't have to pick 6 seconds. You could pick a different time. You could pick 10 seconds and put that value in, in here. And then you'd have to put 10 seconds in there. But use this equation right here. And then the last one, find the half-life of B. Once you find K, then you could plug it into the half-life equation. And if you don't have this sheet, which you won't on the test, the equations are given right here. Here's the half-life equation, and then here's the integrated first-order rate law equation. You won't need to know any other integrated rate law equations other than the first one, any other half-life equations other than the first one, and they're both given to you on the front page. You do need to know these graphs, though. You need to know what 1 over concentration versus time, natural log concentration versus time gives you. Okay, anything else for number 4? Number 5, now this one I think is actually the easiest one on the test. Here are the products divided by reactants to the power of the coefficients. Questions on those? You can use brackets or you can use parentheses according to the AP exam. Usually parentheses are used for KPs and brackets are used for KCs, but either is acceptable. Just remember, don't put liquids or pure solids in there and then you'll be okay. Got it? Okay, and then the last one. These equations aren't given to you, so you need to know that to find delta H, you do the summation of the enthalpies of formations of products minus the summation of the enthalpies of formation of reactants. And so, we look at the products right here, B and C. B and C's products are negative 105.5, which I put right here. And the other product is B, negative 85.2, and then minus negative 287, and then you subtract that and you end up with that for the kilojoules of energy. You do the same equation except it'll be S's for the letter B, and I took them off of the table here. And to 3 sig figs, it's 156. Notice this is in kilojoules and this is in joules. Questions about that top part?
Nope.
Okay, then on the bottom, you use G equals H minus TS. If you forget that equation, it's okay. It's on the front of the test right here, G equals H minus TS. And plug in your H from here. Plug in your S from here. But watch out, the S needs to be in kilojoules. So convert that to kilojoules. And then put your temperature in there that they tell you. And then to find K, use this equation. G is equal to negative RT ln of K. Forget that equation? Well, it's okay. It's on here for you. G equals negative RT ln of K. Plunk and chunk. You get that for K. Got to undo the logarithm.